So in this video, we're going to talk about the next topic of the exam, which is cloud service types. Now, we've already alluded to it in the previous section of the course, and that is there are primarily three types of cloud services. There is the infrastructure as a service, there is platform as a service, and there is software as a service. We also saw this when we're talking about the shared responsibility model of cloud computing. Now, when you hear the term as a service, you should think of it as being something that you would normally have to buy, but instead you can rent it. So instead of purchasing a car, you can rent a car. And so a car rental is a car as a service. And so in this case, you can rent it, or at least you don't have to own the equipment. You can just use someone else's equipment for a short period of time. There's also the possibility of having no commitment. So you could literally create a server at 1 o'clock in the afternoon, and by 3 p.m., shut it all down, and the costs end there. So you don't have to sign up for 1 year or 3 years. Now, cloud computing providers like Microsoft Azure do have commitment options for significant savings. So if you know that you're going to use 30 or 40 virtual machines in the coming year, you can actually commit to that, and you would receive more than 50% off the costs of those servers by making that 12-month commitment. And the other feature of as a service is typically you're charged based on either time or gigabytes or some metric of usage. So you generally pay for what you use. And the corollary of this, of course, is the cloud provider. In this case, Microsoft Azure is responsible for buying the servers or developing the software, maintaining it, taking care of updates, security, a lot of those underlying things. And we saw this in the shared responsibility model. The cloud provider is responsible for that type of stuff. So infrastructure as a service is pretty straightforward. These are the essential services of IT that you'll be familiar with, including computing services, storage services, and networking services. And generally, these low-level services in infrastructure as a service have real-world equivalents that you would use in your own data center. So you can know what a Windows computer is, because that is a server. And so you would have a server in the cloud, and that would be infrastructure as a service type. So these are cloud replacements of what you would consider to be real-world hardware and wires and cables, hard drives, computers, and things like that. So if we look at infrastructure as a service in the field of computing, we're looking at something like Azure virtual machines. So these VMs are going to be infrastructure as a service level. You get a Windows server or a Linux server with nothing else installed. And it doesn't do much. It just sits there until you actually install your own software or third-party software and make it do something. Virtual machines happen to be paid by the second. So if you use the machine for 3 hours, 12 minutes, and 15 seconds, that's all you end up paying for. You get lots of choices in CPU speeds, in the actual CPU hardware, AMD or Intel. You get RAM sizes, and some of them are optimized for memory, optimized for I/O speeds, optimized for CPU or general purpose. So there are many different optimizations and even high performance computing. On the storage side, when you're looking at infrastructure, we're talking mostly about something like Azure storage. So this is the equivalent of a hard disk or a solid state disk in the cloud. An Azure storage account gives you 5 petabytes of storage capacity and handles different types of files, such as blobs, regular files, queues, and even a type of storage table. It's very cheap, and so you're looking at sometimes 2 cents per gigabyte per month for storage in the cloud. And there's even for big data applications the concept of a data lake, and you can configure your storage account for petabytes and exabytes of data using a data lake. Another type of IaaS is networking services. And in this case, we're talking mostly about something like virtual networking. And actually, virtual networks don't actually cost you anything. So you can create a virtual network and subnets, and there's no cost for that. But there are bandwidth costs. So bandwidth is another type of service. The ingress, which is the inbound data into Azure, and egress is data leaving Azure. And those have costs. There's, of course, a free tier. You get 5 gigabytes ingress per month, and you pay for... ingress is free, and you get 5 gigabytes of egress per month free, and then you'll pay for traffic between regions. The second type of cloud service is a platform as a service. Now, on top of this basic infrastructure, cloud service providers do sometimes provide more than the basics, and these are sort of like infrastructure plus some type of software layer. So you can take computing, storage, or networking and add a managed layer on top of that with some features and functions, and make your life a lot easier. So this is like middleware, development tools, deployment tools, database servers, and more that can run on top of these basic hardware layers. So in the computing space, one example is Azure App Services. With an app service, you simply just package up your code into a type of zip file and your configuration variables, and upload that into Azure, and Azure will run the code in an app service, and you don't have to worry about the virtual machine underneath. It includes additional features. This is the plus element, like scaling, auto-scaling, continuous integration, continuous deployments. There's a container option in Azure App Services. You've got deployment slots, which provides development and staging environments, and many, many more. So there's a whole bunch of features that don't come with virtual machines. The storage option for platform as a service might be something like managed storage as an example. I also think of databases like Azure SQL Database as being a type of storage. And that's another example of a platform. So when you have a platform as a service storage, you're basically freed from worrying about the stuff that's underneath, the hard disk, how full it is, performance, IOs per second, things like that. Now we can also talk about networking. Now there's a number of services like Front Door, Load Balancer, the firewall service. There's Traffic Manager. There's a bunch of types of services that deal with traffic, pushing them to different regions, load balancing those virtual machines in the same region, etc., that are essentially software applications that perform networking tasks. Finally, if we talk about software as a service, these are typically apps, full-fledged apps. You have to create an account, you log in, like Office 365, OneDrive, Skype, Dropbox, and Google Drive and Google Docs, and all of these things that are in the cloud. These are software as a service. And with software as a service, the app is just ready to be used. It's not like a platform. A platform is got lots of functions and features, but doesn't do anything until you fill it with stuff. Like the app service is just effectively a computing environment that has lots of functions. Whereas software as a service is an app. And you go in there, there's a menu, it does stuff, and within minutes you can be going once you do the basic setups. So those are the 3 cloud service types. So in this video, we're going to talk about the concept of serverless. Now you may have heard this term. It's a bit of a buzzword, and it's very popular in some services and some circles. But the concept of serverless effectively is a pricing model. It also abstracts a little bit from the underlying hardware. So when we say serverless, we're not actually saying there are no servers. We're actually saying there are servers, but you aren't really conscious of them. You're not picking the hardware. You're not picking the speed of the CPU or the amount of memory that particular server has. So there is some services in Azure that have both a platform as a service option as well as a serverless option. So I want to highlight this as basically a difference between pricing model. You're basically paying for the service and not renting hardware. That's kind of the difference that I take. So I'll give you an example. So let's look at the pricing for SQL Database. So SQL Database is a platform as a service offering, and this is what's called the DTU pricing. You're basically picking a tier from S0, S1 all the way beyond S9. And you're getting a certain level of performance that's represented by the DTUs. That number is a relative measure of performance. So the 10 DTUs gives you a certain amount of performance, and 20 should give you double the performance, and 50 should give you 5 times the performance of the 10. But you can see it includes storage, it includes obviously the CPUs required, and it basically charges you per month for SQL database access based on this simplistic measure. Now, some years ago, Microsoft introduced another pricing option, which is called vCore. And in this case, you can pick specifically how many cores your SQL database has and how much memory it has and how much storage you use. And you're going to pay, this is a more complicated pricing model, but a lot of companies want very specific amount of CPUs and don't need as much memory. And they want to separate out all of the limitations of the DTU model. And so you can see you can even pick F-series CPUs based on Intel Xeon Platinum, and there's different sets of hardwares you can choose between, different pricing. So that's the standard platform as a service pricing for SQL database. When it comes to serverless, you just get one option and one price. So you can see that it says standard series, and it does tell you a little bit about the hardware options, but it's basically E5 Broadwell, Intel Skylake, Intel Cascade Lake, and the Xeon Ice Lake. And so you've got 4 different potential CPUs, but you're not picking which one. And you can see it also has a minimum and a maximum. So what that's implying is that Azure is going to take care of it for you. You hand your database over to Azure, and depending on how popular it is, how many requests are made to your database, it's going to scale it from between a half a CPU, 1, 2, 3, 4, all the way up to maximum of 80. And you're paying per CPU second. So you can see on the right, the pricing is 1/100th of a cent per CPU second, something like that. Much more difficult then to calculate how your database is being used, because it can fluctuate between half a core all the way up to 80 cores, depending on how many requests per second are coming in. So you're not going to know at the end of the month in advance how much your bill is going to be, okay, because of this dynamic nature. One of the advantages of serverless SQL database is that you could have 0 cores. So in fact, when your database is not being used, after, let's say, 1 hour of idleness, you can have it spin itself down, and then you end up with several hours of no costs. So serverless SQL database can be the cheapest option for databases if you have a very underused database, right? So if it's just a development database or it's just occasionally queried, you can actually set that to spin down to 0, and it will shut itself off when it's not being used. So there are some additional features of this serverless, but the pricing in some ways simplified because you don't have any options, but in other ways you can't predict at the end of the month what your price is going to be. You'll find this is also true for the other serverless offerings. So one of the first and maybe more famous serverless offerings is called Azure Functions. And when you set up a function, you can choose between an app service plan, which is a platform as a service, or the serverless offering. And it has a very generous amount of free executions, 1 million function executions per month free under the serverless option, which is plenty. And then you're going to be charged a fraction of a penny for additional 10,000 executions, etc. So a lot of these serverless options, you can save a lot of money. Microsoft is basically offering you the service, and they're taking care of provisioning the hardware, provisioning more if it needs more, provisioning less if it needs less, competing with other customers for those resources, etc. So serverless has become very popular. Again, it can save you a lot of money. The pricing is not predictable, and it also could be free in a lot of options like Cosmos DB and things like that. So check this out if you're interested in another alternative to the traditional pricing structure within cloud computing. Now we've completed the first major objective of the course, and we're moving on now to the second objective, which says describe Azure architecture and services, and is worth 35 to 40% of the overall score. So this is obviously a massive section. Now we're getting away from generalized cloud computing concepts that were maybe relevant to other cloud providers and focusing on Azure itself. And so in this section of the course, we're going to be talking about the core architectural components. This includes regions and region pairs, availability zones, data centers. So these are the fundamental building blocks of how you can create solutions in Azure. And in the following sections, we're going to talk more specifically about compute, about networking, about storage, and about Azure Active Directory and all of the security and identity related services. It's a lot. So you can see 35 to 40% of the score, and we're covering a lot of topics. So we're going to start with the core Azure architecture services. And so in this section and in this video, we'll talk about regions, region pairs, and sovereign regions. So these are sort of related concepts, and hopefully it's pretty straightforward. Now, I've used some of these words before, regions particularly. What is a region? So Azure breaks the globe up into just over 60 separate regions for where they have a presence. And so it is essentially a set of buildings, data centers, that are combined together to make up a region. Now, sometimes they're named after the country that they're in, and sometimes they're not. Some countries have multiple regions in them, like the United States, and some only have one. Most don't even have one. So the other concept is this region pair, where Azure has divided their regions, basically matched them up so that every region, almost, has another region which can be called its pair. It has the fastest connection, in terms of the fiber optic cables that connect the two regions. If you're doing any kind of backups or massive data transfers, the connection between the two paired regions is going to be the fastest connection. And they actually treat them specially when they're doing rollouts to Azure updates. And so they're not going to do both of these regions at the same time in case something goes wrong. And so if you're going to put your duplicates of your services in a second region, then it makes sense to choose the region pair because of this special relationship. You don't have to, but it is there for your usage. There is a really cool map. If you go to infrastructuremap.microsoft.com and click through to the map of it, it's a really cool 3D map that you can see all of the regions of the world that Azure has a presence, and explore that for yourself. I'm just going to take some screenshots here and share it with you. Now, this is the flat map, so we can see the traditional map of the entire world. And the blue dots, the light blue dots, represent Azure regions. And so we can see that North America, particularly the United States, has quite a lot. Western Europe has quite a lot. We're seeing more and more into Middle East and India and into Asia and Australia. So there's some concentrations there, but this is where the business is. And you can also see on this diagram, if they're very faint, so you'll have to be watching this at 1080p, but you can see the high-speed connections between the different regions. There's cables under the sea, and these are represented by lines that are connecting North America and Europe. They're surrounding Africa, they're surrounding South America, things like that. So that's really a good overview of all of the different regions of Azure and all their other things. If we zoom in a little bit, we can see United States here, Canada and Mexico. Canada has 2 regions. Right up here, there's the 2 regions in Canada. United States has quite a few. There's 2, 4, 6, 8, 9 regions in the United States. And one, this light gray, is called Coming Soon. It's US East 3. There's also a Coming Soon region in Mexico. And so you can see North America has quite good coverage. If we go over to Western Europe, that's quite a dense set of services, and of course it's quite a dense population. So all of the blue dots represent places that they already have data centers and regions, and the gray dots represent places that are coming soon. So there are, here's Greece, for example, that has one coming soon. Spain has one coming soon, etc. Now, we can even see here into the Middle East, where you've got Saudi Arabia, you've got Qatar, places like that. There are data centers being developed, more coming soon in the Middle East as well. Now, one, dark spot, I guess you could call it, is, let's say, the case of the African continent, where there really is, we've got South Africa, so down here is South Africa, but you can see some points of presence, so there's connectivity. The undersea cables reach the mainland at a certain points, but the data center, if you were to use it, is in South Africa. Hopefully, in the coming 1 decade or 2 decades, Africa is going to be a hotspot for development and business, and companies like Microsoft will build more data centers and regions within the African region. So let's look specifically at a couple of examples. Let's look at Canada, for instance, place near and dear to my heart. Canada has 2 regions, Canada Central and Canada East. They were developed in 2017, I believe, so only about 6 years ago. And there is this concept of data residency, and so data that is stored in either of the Canadian regions is kept in Canada. So Microsoft does a pretty good job of making sure that data privacy laws of various countries and regions are being respected. And so if you store your data in Canada, then the data does not leave Canada. But anyone in the world can use these regions. So if you're in America, if you're in Europe or Asia, you can install virtual machines and database servers and storage in Canada if you have a reason to do so. One of these places is an exception, and Brazil is one of the exceptions. Brazil has only one region, so the Brazil South region. It's one of the few places that only has a single region. It is currently the only active region in South America, although Azure has announced a Chile region that'll be coming online soon. Now, there is the concept of a region pair, and fortunately. Brazil is paired with the United States, South Central US specifically. So it is a one-way pairing. So data stored in Brazil South will be backed up in South Central US, but data stored in South Central US will not be backed up in Brazil South. So it's kind of a unique situation. That means that if you store your data in Brazil, there is no data residency concept because the data can be backed up to the United States. Another interesting difference is a country like Qatar. Qatar is the first region in the world that does not have a pair. So Qatar is a solo region that's unique. That means you cannot use GRS, geo-redundant storage, in Qatar for storage that's primarily in Qatar. You're going to have to take care of your own backups and redundancy. If you want to store stuff in Qatar, but you also want to have a backup of it in another region, that's up to you because GRS is not available. We haven't talked yet about availability zones, but it does support availability zones, and that is the main reason that the main way that Qatar is going to support high availability. Here's a list. I just picked out a few of the pairs, 6 of the pairs. I said there's 2 regions in Canada, so Canada Central and Canada East are obviously a natural pair. North Europe and West Europe are also a pair. These U.S. regions, East U.S., West U.S., East U.S. 2 is Central U.S., and we see here that Brazil is a one-way pair with South Central U.S. So to back up here, if you go to create a resource like a virtual machine, a storage account, or a database in Microsoft Azure, you do have the choice of which region of the world to deploy it to. Right? There's not really a concept for most resources of Azure picking the region for you. It's going to deploy it to where you tell it. Sometimes the pricing is different. So if you have a storage account in one region versus a storage account in another, there might be slight differences in the pricing. Now, there are over 60 regions, and some of them are coming soon, but most of them are not available to everyone. What that means is when you log into your Azure account and you go to deploy a virtual machine, you see the drop-down of the regions. There's going to be 30 or 40 choices in there, but there's not going to be 60 choices. There's some restrictions. So some regions you have to be a resident of that country in order to deploy stuff to. In other cases, there's sovereign regions. You have to be part of that special club. And we'll talk about sovereign regions now anyways. So sovereign regions really are connected to usually a country or a government. They are a completely separate thing compared to the Azure public cloud. We talked in the beginning of this course about public cloud and private cloud and hybrid cloud. But a sovereign cloud is really disconnected. You cannot expect private resources in a public cloud to be able to connect to private resources in the sovereign cloud. It just wouldn't work. In order to even be a user of the sovereign cloud, you have to have approval to join. You won't be able to create a subscription just like you would with your credit card as a public cloud. And of course, there's different privacy and compliance standards. We'll see this in a second, but every sovereign cloud has a different sort of set of standards that it needs to follow. So here's an example. So there are, and this is in the United States, I guess, 4 types of clouds. We've got the public cloud on the left. Azure Commercial is the public cloud. Now, it does follow a couple of the high-level Department of Defense Impact Level 2 standard, FedRAMP as well, and HIPAA. So if you are a governmental client and you don't really have security concerns and it's not that type of application, you can use the Azure Public Cloud, but it does follow these compliance certifications. If you look at the Azure Government option, Azure Government is for government workers and governments. So you have to be a U.S., state, or federal government employee and department in order to get access to the government cloud. You can see that it does support higher level of or lower level of impact standards for Department of Defense, depending on how you look at it, the FedRAMP High standard, and some of these other defense standards. There's also a secret cloud. So this is for, governments have secrets, I guess. And so this is, let's say this is more for typical state and local usage, whereas this might be for, secret operations, right? Intelligence services. And there's a brand new thing called the top secret, and it complies with these sets of standards. And there's not much information about that, as we'll see in a second. So we can look at the list of government regions. We have here on the left a couple of Department of Defense regions. So these are obviously limited to the military, and locations, the dates that they are available. Obviously, the data never leaves the United States. Physically isolated, so it's not physically connected to the other Microsoft Azure. And it's reserved exclusively for Department of Defense. There are more generic government offerings, so you can see there are at least 3 regions for the government services, and it could be anyone in, like I said, state or federal level and their partners. And there's even this, these are the information about the secret government cloud. Now, it's not going to, because it's a secret, it's not going to tell you where they're located. And they, of course, not even going to tell you what types of virtual machines or what type of services are supported. The other type of sovereign region is China. So China, of course, doing business in China is you do have to work with the government there. And so it's a separate company that provides Azure services in China. You need to sign up with an account for this host that's running the Azure China. And it is limited to people who have a presence in China. So you, as an American or Canadian business person, can't just decide to deploy a VM into mainland China on a whim. You do have to sign up for an account, and you do have to basically have Chinese presence. So in this video, we saw that we have regions, which are geographical. They are sets of data centers located in a particular geography, not necessarily at the country level, but they do are more and more are being named after the countries that they're in. Region pairs are existing for backup purposes, high-speed communications, and for the rollout of Azure updates to be in the most safe manner. And then we have our sovereign regions, which are basically U.S. government, secret, top secret, Department of Defense, and China. So now we're moving on to talk about availability zones. Now, availability zones are effectively data centers or sets of data centers that are physically separate within each region. Now, sometimes you'll see that Microsoft has a pretty big piece of land, and there could be 2 or 3 or 5 buildings on it, and those are 5 separate data centers. And you can, group a couple of those together to make an availability zone, but other times the data centers will be a few miles apart, a few kilometers apart as well. It's possible for both. So thinking about what we just learned about regions, so let's say, Canada East region or Canada Central region has availability zones. Then what you have are 1 or more data centers that are representing each availability zone within that region. Now, these are very high-speed connections, 5 milliseconds connections between these data centers, and they are physically separate in separate buildings. They have their own power, they have their own cooling, their own connections to the internet. They're not reliant on each other for anything. So they have their own infrastructures. Now, it's important to note that not every region supports availability zones. So I just mentioned Canada Central has availability zones, but Canada East does not. So Microsoft has been slowly converting legacy regions into availability zones, but not every region needs them. So if you, as a customer, are finding the concept of availability zones appealing, then you're going to want to make sure you deploy your resources into regions that support availability zones. If this is not something that you need, then you don't need to worry about which region you deploy it to in this respect. Now, many regions have availability zones now, so you can see on the Americas on the left, Brazil and Canada have them. 6 regions in the US have them, and the US government region in Virginia. But not the other regions do not have them. Europe, we see on screen listed the regions that have them. Poland, coming soon, will be part of this as well. There's a couple of regions in Middle East, South Africa, and some regions in Asia Pacific region. So if availability zones are important to your business, then you would want to deploy it to one of these regions. Now, it's also important to note that not every region has availability zones, but not every service supports the concept of availability zones, although it's quite pervasive. So as Microsoft redevelops and enhances these services, the new versions of them sometimes support availability zones. We do need to know that there are types of services that support availability zones. Not all of them are identical. And so we're going to talk about zonal services, zone redundant services, and the concept of always available services. So zonal services is basically you as a customer choosing to deploy your resource to a specific availability zone. So to give the example of a virtual machine, if you wanted to deploy a virtual machine to Canada Central, you can optionally choose to deploy it to availability zone 1 or availability zone 2 or 3. So this is your choice. Now, why would you do that? You do this because you want to have your resources in that region, Canada Central, but you do want to have them redundant so that if there is a power outage or an internet outage, it lowers the chances of everything being affected. So you can deploy some resources to availability zone 1 and the duplicates of those resources to availability zone 2. And with appropriate application structures in place, then if zone 1 goes down for whatever reason, zone 2 is still running and your application continues to run. So those are zonal services, right? You can choose or not choose to deploy to a specific zone and control that. Now there's a zone redundant service. That is a type of service that supports availability zones, but you don't have to worry about deploying to specific ones. This is automatic. So like Azure Cosmos DB or Azure SQL Database, you deploy to a region, it's going to deploy your database to more than one zone, but you don't get to pick the zones, and it's something that's taken care of for you. So those are zone redundant services. Finally, the concept of always available services. So these are like global services, and Microsoft runs them globally. They're not specific to a region, and they're ensuring that they're always going to be available. So if a single availability zone goes down, then an always available service should not be affected. These are also sometimes called non-regional services. And I'll give you an example. The Azure portal itself is a service, and it's a global service. There's not a single region that the Azure portal runs in. Active Directory is another. And there's services like Azure Front Door, where you're creating profiles for your applications, but again, you are not deploying Front Door to a region. And there are actually services such as the Azure Application Gateway or the Azure Load Balancer that when you're deploying them, you get to choose to manually deploy them into zones or deploy them as a zone redundant method and let Microsoft take care of it for you. So some services are actually quite flexible that way. So next up, we're going to talk about a concept that I may have alluded to a few times on this course, and that is the concept of an Azure resource. And we'll also then talk about resource groups. Now this diagram, we're going to come back to this diagram a few times in this video and the next couple of videos. And it shows to you that there's a hierarchy of resources within Microsoft Azure. At the lowest level, you have the actual resources themselves, and we'll define that in a second. Above those, you're going to have resource groups, above that subscriptions, and above that management groups. And we'll talk about each of these terms. So at the lowest level of that diagram was resources. Now resource is just a generic word that represents any Azure service that you have access to. So it's like an active or instantiated Azure service, such as a specific virtual machine, a storage account, or some type of database. Any of these services that are active and you have access to them, you can call them resources. And there are many different ways to create a resource. You can create them through using the Azure portal, the command line, including PowerShell. You can create them using ARM templates or Bicep, but there's a number of ways to create resources. Now, resources are generally named. I was trying to think of a type of resource that you didn't give a name to, and I couldn't think of one off the top of my head. So generally, you always have the option of giving a name that you may recognize to a resource. Microsoft does recommend that you adopt some type of naming convention so that you will know by looking at the name who it belongs to, what its purpose is, what project it's part of, etc. Sometimes that name has to be unique across all of Azure. Sometimes it only has to be unique inside your resource group, and sometimes not even that. And in general, you're going to deploy resources and you have to give them a location, a region where they will be created. And this is, we just talked about regions, but this is the geographical aspect of where you want your resources to be running. On the Azure portal, there's a tab called All Resources, and you're going to see a list of all the running resources against your subscription. Now, if you just created a brand new subscription, this is your first 10 minutes within Azure, you're not going to have any resources. Your resource tab is going to be empty. You can create resources using the Azure Marketplace. When you do, you're going to start to incur a cost. Now, you could be on the Azure free plan. Maybe you have some credits associated with your account. But nonetheless, whether you have credits or you are paying for it yourself, most resources have costs. And when you do create a resource, that resource is associated with what's called a subscription. Only one subscription per resource. And that's where the cost gets billed. So we saw the resources are the actual things, the virtual machines, storage accounts, and databases and such that you can create. Next up is the resource groups. So resource group is like a folder or a container structure. It is a way of grouping resources together. When you do create a resource group, you do have to associate it with a region, but that does not restrict you because you can put any resource into your resource group, even if it's from a different region. And in general, Microsoft recommends that the resources in a resource group should have some connection with each other, that they are created around the same time, or they will be managed together or deleted at the same time. Don't put things that are disparate and not at all related to each other in the same resource group. You're taking away some of the power of the resource group. So, just like a subscription, a resource must belong to one and only one resource group. And you can actually assign permissions like read and write and delete and create permissions at the resource group level. But do keep in mind, beyond the permissions that you assign, there's no security boundary offered by the resource group for the resources inside of them. So any resource can access any other resource in another resource group, except if there are other security. So the resource group itself is not offering any intra-Azure communication security. So hopefully that was clear. This is the difference between resources and resource groups. So let's talk about the next concept, which is subscriptions. Back to this diagram that we mentioned in the last video, we've got resources that belong to resource groups, and in this way, resource groups belong to subscriptions. So a subscription is basically a billing unit within Azure. And there will always be some type of payment method associated with a subscription. It could be your credit card, it could be your account with Microsoft in terms of another type of billing method. And as a user, you are free to be associated with more than one subscription, and you can actually have different roles. You could be an administrator in one, you could just simply be a low-level user in another, and anything in between. There are different types of subscriptions. So there are things called subscription plans. You should be familiar with the free plan. We already know you get 200 credits for the first 30 days. There's a number of free services for 12 months. And that basically, once you've used the free plan, you cannot create another one. So it's a one-time use only. The next one is pay as you go. So this is as a small business or an independent person, you give your credit card to Azure, and as you use resources on a monthly basis, you will be billed for that, and it'll be auto-deducted from your credit card. And as I said, you can have various business relationships with Microsoft or one of Microsoft's service partners, and so you can have some type of enterprise agreement or service partnership. Also, there are subscription plans that come with your MSDN subscription, or if you're a business startup, or there's student plans. There's a lot of different types of subscriptions. Now, like I said, it is possible for a user to be associated with multiple subscriptions, and it's not all that uncommon for big organizations to have multiple subscriptions. And generally what you're going to want to do is use it to separate out the disparate parts of your businesses that don't really need to interact. So you can have a subscription for the sales team, and a subscription for the IT operations, and a subscription for marketing, etc. Another way you could use this is by business geography. So if you have businesses located in North America, they can use one subscription. Businesses located in Europe can be another. Here's an example of a company that has 3 Azure subscriptions, and they're consuming all different services, the resources inside. And again, the purpose really is just to separate out the billing. Some companies use it as a hard line for security reasons as well. You do not want anyone in the marketing team to accidentally and inadvertently get access into the finance subscription. And so at the subscription level, it's a lot easier and more certain to do that, because if a user doesn't have an account in the finance subscription, then they're not going to have access to any of the resources. But this is not required, right? So it is entirely possible for a large organization to run on a single subscription. You just have to make use of the security that is available, RBAC, and ways of separating out your users so that they don't get access to things that they're not supposed to get access to. So we're going to finish up here talking about management groups. Now, we were talking before about resources and resource groups and how they belong to subscriptions. Well, subscriptions have their own organizing thing called a management group. And so you can create, it's optional, create a management group that can contain one or more subscriptions, and that allows you to manage the subscriptions on a group basis. Now, this diagram is slightly better at explaining it, and you can see that this company has, in this hypothetical example, 4 subscriptions. There is a dev test subscription on the left that belongs to the marketing team. The center contains 2 enterprise agreement subscriptions for the IT team, and there's a pay-as-you-go subscription for the application team. Remember, I talked about the different subscription types. And so these are organized into groups, but further, the groups themselves can belong to other groups. And at the very top, you have the root. Now, the management group allows you to basically control these subscriptions from like I said, one centralized place, you might have different people who have management, administrative capabilities for these different subscriptions, but you still want to enforce certain policies on them. So you can put together what is called a Azure policy or a blueprint, and you can basically assign certain resource groups, ARM templates, policies, and stuff to the subscriptions, and you manage that at the management group level. So this is really just a way of enforcing some security and policy to a group of subscriptions, and this is a way of enhancing security, obviously. So let's move on to the second objective of this first section, which says describe Azure Compute and Networking Services. Now we're getting into the specifics of Azure here, and you can see a bunch of Azure services, including virtual machines, virtual machine scale sets, app services, and the like. So this section of the course, this video and the videos that follow, are going to cover both compute and networking services. And we can see also it covers virtual networking, VPNs, DNS, and things like that. So let's talk about the computing services available in Microsoft Azure. Now, I look at computing services as being one of the four, what I'll call technical pillars of Azure. So these are infrastructure level services. These are foundational. You're going to build your solution on top of services such as this. So we have a whole category of compute services. We'll talk about that in a second. We're going to talk about networking services. And there's also storage services, and a subcategory of storage would be including database services. So what are compute services? Well, it's basically your desire is to execute some type of code in the cloud. This could be in the form of a website. This could be some type of app. Maybe you're a bank and you have banking functionality. People log in, they view their accounts, they can do transactions. That stuff happens on servers, and those servers are hosted in the cloud. Now, Microsoft Azure has, about a dozen types of computer services, and this is just some of them. So what we're going to talk about are virtual machines. That's one of the fundamental types of compute in Azure. We're also going to talk about scale sets, which are an abstraction on top of virtual machines. We'll talk about web apps, which are a cloud native form of running applications in the cloud. There's a whole type of container services, including Azure Container Instances, Azure Container Apps, and Kubernetes. And finally, this deserves a category of its own, but Azure Virtual Desktop, which we'll see in a second, is basically allowing you to run your desktop as a cloud service. So you can access your computer desktop, your workstation, from anywhere. So let's get into it. Now, the first and maybe most important type of compute services are the virtual machines. Now, to me, this is the closest analog that we have to what you would consider to be a computer or a server in your own environment. So if you have a server under your desk or in a room at the back of the office or hosted in another hosting provider, then you have full and complete control of that server. You can install whatever software you want. You can go into the server settings, go into the registry of Windows, or go into the settings of Linux and make changes to that server, reboot the server at any time. The server is yours to do with whatever you wish. So a virtual machine is an analogy to that, but it's virtual. Now, what makes a server virtual? Well, basically, you've got a single physical machine that's called a host that has been subdivided into slices, and you can rent any single or multiple slices of that machine. So you can think of it like, instead of owning the entire 64 CPU computer, you only have 8 of those CPUs that you can use, and then the other 56 of those are dedicated to other customers. So we start off talking about the standalone server. I like to make an analogy with a house. So if you have a single detached house, you've got a piece of land and a house on it, that's your house. You can do whatever you want, basically within zoning laws, of course. But basically, you can do whatever you want with it. It's your house. If you want to, knock down a wall and put a new wall or whatever, as long as you get planning permission, you can do whatever you want. And it's actually very difficult to do things to your house that's going to directly affect your neighbors, assuming soundproof walls, like, obviously you can disturb them through sound, but that's not really relevant to computing. So houses are standalone things, and whatever happens inside of them are private. No one can peek inside your house with the windows closed and the drapes closed to see what's going on. It's completely private, and you can't really disturb your neighbors. You also have your city services like your garbage and your sewer and your water, and these are things provided by your local municipality. But all of your other services are your own. Your air conditioning is your own. Your refrigeration is your own. If you have a pool, that's your own service that your neighbors can't borrow. So a standalone server is like a single detached house, basically. Now, when we get into the topic of virtualization, just as a general topic, so if you take your single detached house and instead of building a house on that land, you built an apartment building. Let's say you built 8 apartment units on that same land, same size land. Well, the virtual machine is basically one apartment in that building. All right, so there are some common services, like you've got your garbage that is usually managed by the building, sewer, water, electricity, that stuff all goes through the building. And then there may be some shared services. So you've got your reception area, your mail room, gym, heating and cooling, snow removal, or landscaping. Like, there are services that are provided to your building. Sometimes there's an HOA fee or a condo fee. Other thing too is it's generally cheaper to rent an apartment than it is to rent a whole house, right? Because if you think of that apartment is not entirely equivalent to a house. But that's why people move their servers into the cloud, because they get all the benefits of having a house, but they're not owning a house. So basically, when you're inside your own apartment, this is maybe a bit of a stretch, but once you're inside your own apartment, there's not really anything that's telling you that you rent it versus you own it. There's no differentiation in looking at the house. The sofa is the same, TV's the same, the kitchen's the same. When you're inside the apartment, it's a place to live, and you get all the same services as a homeowner would get. So when we move into virtual machines are what are called infrastructure as a service, or IaaS. You'll see this label applied to certain types of services. Virtual machines is one of them. You can make a copy of your existing machine, so your desktop computer or your server, make a copy of that, turn that into an image, and deploy that into the cloud. It supports both Windows and Linux operating systems, many different distros of Linux as well, not just any single one. Many different versions of Windows. You've got your server Windows, you've got your desktop Windows as well. Again, the virtual machine is a slice of a physical machine, and there are other customers that are using that same physical machine, but you're not going to be able to tell. You'll have full control over Windows or Linux, just as if it was your own machine. There are some subtle differences, but basically it's almost identical to running a physical machine, except for a few minor things. If you know anything about AWS, what Microsoft Azure calls a virtual machine is called an EC2, Elastic Compute Cloud, in AWS. Now, when you go into Azure, and we'll do that soon, go into the portal and you start looking at all the different types, you can't just arbitrarily enter numbers to say how many CPUs you need, how much RAM you need, how much disk you need, how many operations per second. Microsoft provides predefined images to choose from in terms of virtual machine types. And so there's over 700 at last I checked. It might be more now. but you'll find something to meet your needs within those different types. So we're talking about virtual machines. In the next video, we'll continue talking about the other types of compute. So now let's talk about scaling virtual machines. Now remember, scaling basically allows a machine or an application to handle more traffic as demand grows. And so you can scale a VM in one of two ways. One thing you can do is you can just increase the size of the VM instance. And it's pretty easy to do. You can have a 4 CPU VM and very easily go into the 8 CPU version of the same family. This is called scaling up. You can go from 8 to 16, 16 to 32, 32 to 64. Now, once you go above 64, there are some different options. Some instance families have 96 CPU versions. Some instance families have 120 CPU versions. But that's pretty much the limit. As you get into the 3 digits, the 100 in CPUs and up, is pretty much the max you're going to get. So what do you do when you need a bigger and bigger machine and you need to go over 120 CPUs? Well, the second option for scaling is to increase the quantity of virtual machines. You can have more of them and have them working together to handle whatever type of work that you're getting them to do. Now, obviously, you're going to have to design your application to work when there's multiple servers doing the same work without them duplicating work or conflicting with each other. But the preferred way of scaling is to scale by adding more machines, and this is called scaling out. So increasing the size of it is scaling up, but there's a limit. Increasing the quantity of VMs is scaling out, and there's not really a limit. And so what you might want to do is have more smaller VMs instead of to have one single large VM. Now, one of the ways you can do this is called a virtual machine scale set, or sometimes just a VMSS or a scale set. So a scale set is basically a predefined group of virtual machines that you can add machines to, and you can reduce the number of machines based on some predefined rule. And this is usually based on some type of proxy for demand. So you're actually looking at CPU utilization as a proxy for when a server can't handle the traffic. And then you can automatically add one additional server to handle the increased traffic. And you can keep doing that until the traffic is fully satisfied or you reach some type of limit. That's not the only way you can scale a scale set. You can also have a predefined schedule. So let's say Monday to Friday, 8 a.m. to 8 p.m., you need to have 5 machines running. And then from 8 p.m. to 8 a.m., you only want 2 machines running. So you can have a time-based schedule if you want, or there's a number of other factors, including the queue length or message queues or other types of ways you can scale a scale set. So to summarize, a scale set fulfills the elasticity requirement of cloud computing. It is usually 2 or more virtual machines running the exact same code. There's no point having machines in a scale set if they have different code on them. They should be identical. Either machine can do the work equally. You're going to use what's called a load balancer in front of the machine. That's like a traffic cop. And that's just going to randomly direct traffic from A to B, back to A, back to B, so that traffic is distributed, hopefully evenly, between the 2 or more machines that are running behind the load balancer. Again, the scaling aspect comes from being able to add machines as demand grows or reduce machines as demand slows. This also allows you to save money. In a hosted environment where you've got maybe 12 machines running in your application, you're paying for all 12, 24 hours a day, 7 days a week, 365. But in a virtual machine scale set cloud environment, you can grow to meet increased demand, and you can shrink to meet reduced demand. A VM scale set has a couple of different settings, usually can handle up to 100 virtual machines in a single scale set. It can be configured to handle 1,000 VMs. And if you need more, you simply create additional scale sets and put a load balancer in front of that. So you can always add more scale sets up until there are limits in terms of the number of machines, the number of amount of storage you can have in a single region. So if you're getting up to that scale, you're going to have to bump against the subscription-wide limits. Shouldn't be a problem for most. So that is scale sets. In the next video, we'll talk about other types of ways you can run code in the cloud. Now, in the last couple of videos, we saw that a virtual machine or a virtual machine scale set is very much like having your own server. You have full and complete control over it to install whatever software you want, change the settings, pick your operating system. Now we're going to move into more cloud native versions, things that were specifically designed to run inside of the cloud or inside of Azure. The first of those is called app services, and sometimes called web apps. So in this type of paradigm for running code, you don't have full and complete control over the server. What you're basically doing is you're packaging your code and your configuration, and you're uploading it into Microsoft Azure, and Microsoft Azure will run it according to some type of promise for performance. So you don't know whether it's running on a D2, a D4, a D8. You don't know what kind of server is underneath, but they are promising you a level of performance. This is called Platform as a Service, or PaaS, P-A-A-S, as opposed to Infrastructure as a Service. Now, app services give developers in particular a lot of benefits, make it a lot easier to develop and test their code, integrations with GitHub, for instance, or be able to do A/B testing using deployment slots. And there's lots of benefits to using app services, but the drawback is you don't have complete access to the server. Now, you can FTP into the server to get files. There are logging. There is a console window that you can get, etc. So there is ways to get into the server, but it's not your server. You don't have access to the server settings, and you can't install whatever software you want, only what is supported by Microsoft. Another paradigm in code running in the cloud are called containers. Now, containers are a whole category unto themselves, and basically the concept of container is that you're packaging up all of the files, including libraries, that your code needs to run inside of what's called a container image. So you build this image, and then you can deploy that same image no matter where you want it to go. So you want to go it's a staging environment, development environment, production environment. You can use the same image in all locations without having to recompile the code. Microsoft Azure supports containers basically everywhere. So there is a container version of web apps. We were just talking about web apps. There are Service Fabric that supports containers, but the three main ones that we are talking about these days are Azure Container Instances, which is a quick and easy way to deploy a single instance of a container. Not much scaling options. It's just easy for you to deploy and do a quick demo or run a small inconsequential application. There's also container apps. This is similar to a web service. It has advanced features, but not as complicated as Azure Kubernetes Service, or AKS. This uses clusters. There is its own tool and its own commands. This is enterprise-grade containers. And again, there are other container options, so these are the three that we'll talk about. Now, the final thing we'll talk about in this section is the Azure Virtual Desktop. That is that you have a version of desktop Windows that runs in the cloud. And so when you sit down at a console and you log in as your user ID and password, you're going to get a virtualized Windows desktop. That means that you can go to another console, log out, right? Go to another console, and that same version of Windows, the same files, your local storage, it'll all be loaded. You can then go home from work, log in from home, and you'll have all your software, all your files. It's your desktop Windows available from anywhere. You can even log in using your phone. So there's iOS and Android options for seeing your desktop. And this runs on Azure, which is why it's mentioned in this course. So those are the types of compute that we're going to talk about so far. We've got some more videos coming up. So let's look at the next one, which is Azure Functions. We're still talking about how code is executed in Azure. And in this video, we're going to talk about something pretty cool called Azure Functions. Now, Azure Functions are typically small pieces of code that run entirely in the cloud. It's typically some type of utility function that has a very specific task that it does that takes a small amount of time. Okay, so these are not websites, and these are not long-running programs that take full day to run, things like that. These are basically very simple pieces of code. Not to say that it can't be more complicated, but let's say the core use case is going to be something fairly simple, that it's not worth developing a whole app for, or not worth creating a whole VM just to do this one little tiny thing. Now, functions have triggers. Every function has a trigger, and that trigger can be some type of HTTP call, or again, scheduled by a timer. It monitors a blob storage account and can tell when a new blob is created, monitors a message queue, and runs whenever a new message happens. And there's a whole host of other triggers that functions support. Another feature of functions is could be typically the cheapest way of running code in the cloud. Since you don't have a dedicated VM, you don't have a dedicated app service plan. On the consumption model, it only runs whenever it's needed, and that could be very infrequently, and so you're only paying for when it runs on the consumption model. So there is a very generous free tier that gives you 1 million executions of your code per month free. Again, this is the consumption/serverless model. It also does support more complicated setups. So I'm trying to paint this as being a very simple way to run code in the cloud, but it also can be what are called durable functions, which can have paths and can be long running, require orchestration, for instance. There are also hosting plans. So if you don't want to use the serverless model and you want to pay for premium hosting, you can do that. You can even have functions running on a dedicated server if it's that important to you. So let's talk about some examples of some functions that you might want to set up. So let's say that this function is a small piece of code, and just once a day, it starts up at 12 a.m. and it looks at the database for yesterday, and it summarizes the day and inserts a new row based on that. So just some once a day little function that runs to do one piece of work. It has a start, it has an end, it doesn't run very long. Probably not getting your own dedicated VM just to run this one piece of code once per day. You can have another piece of code called a function that checks the contents of a blob container looking for new blobs. And whenever that files get added, it does something. It moves it, it makes a backup copy, it compresses the image. Whatever it does something every time a new file is added to a blob container. And a third example of a potential function is something that, let's say you just have this weather widget on your homepage of your website, and every 6 hours you need to go call the weather API from some fictional local forecaster and download the weather, and that file gets stored somewhere, or the table gets updated, and that'll update your website. So just running an API externally once every few hours is a type of function you can run. There's lots and lots that we can come up with, but these are 3 examples, just to give you an idea. So now we're going to switch to talking about the other foundational piece of computer infrastructure, and that is called networking. So how does networking work within Microsoft Azure? So Microsoft calls them virtual networks, or sometimes it's called VNets. Now, you know, and we saw this in the beginning of this course, that Microsoft has a global, extensive network, a physical network of cables and switches and routers, satellites going under the ocean, etc. So they have a physical network all set up, connecting all of Azure's data centers and other endpoints together. So we saw this globe in the beginning of this course. But what we're talking about in this video is virtual networks. Now, I can say this pretty straightly. We just talked about virtual machines. By default, 2 virtual machines in Azure would not be allowed to connect to each other, to discover each other, to even know that the other one exists. This is a basic tenet of security. Now, by having virtual networks, then what we can do is we can start to set up the connectivity between virtual machines. Now, virtual networks are considered infrastructure as a service, just like virtual machines. And so it has an analog to something that we deal with in the real world, which are the physical networks, the cables and the networking equipment we would set up in our own office or in our own data center to enable connectivity between our applications on our own premises. But within Azure, that network already exists, but like I said, the security will be pretty locked down. So it's called a virtual network because effectively it's just a database entry within some database in Microsoft Azure, and it establishes the allowed rules for the connectivity between one VM and another. So let's talk some basics about virtual networks. When you create a virtual network, you can define an address space. Now, an address space is basically an allowed range of IP addresses. It can be IP4 or IP6 or both. So you create a virtual network, and at the time of creation, you define a range of IP addresses. Now, it is possible to modify that range to add additional ranges, multiple ranges to make up a virtual network, but at creation, you give it an address space. Now, these addresses are private. And what I mean by that is it's not accessible by any other computer on the internet. When you have a private IP address, there is no path from your desktop computer to that machine using the private IP address. It is completely restricted to the network that it lives on, and there's no other path outside. Now, when you have created a VNet or a virtual network, you are going to generally assign a large quantity, a large in size address space. So you're talking about tens of thousands or hundreds of thousands of potential IP addresses to support potential future growth. It allows you to divide up your VNet into smaller networks And remember, since these are private addresses, we're not going to be stingy here. You don't have to make your private VNets as small as possible. You can be quite generous because there is no shortage. There are millions of private IP addresses that are available for you to be using, and you'll never use them all. Now, VNets don't stand alone. There are these things called subnets. And subnets are a subdivision of a VNet. And there's a minimum of one subnet, but you can often create more subnets as long as they inhabit IP address ranges that are unique within the virtual network range. So when you create the subnet, the IP address range the subnet gets is a subset of the parents. You can't have addresses that don't exist in the parent as part of a subnet. Now again, the security is still paramount, and so usually you're going to be talking about a security layer between subnets that restricts traffic from having to match certain rules in order to pass through, and we'll talk about network security groups in a second. So we have our virtual networks and we have our subnets. Now, how does virtual machines work into it? So a virtual machine must belong to at least one subnet. And the thing that connects the virtual machine to the subnet is called a network interface card, or NIC. Now, it is possible to find a virtual machine instance that has more than one NIC, and so that means you can connect to more than one subnet, and it'll be assigned more than one private IP address. Now, it is possible to get a public IP address. That's a whole different thing. And then you assign each VM its own public IP address, which makes that machine directly accessible from outside Azure. Now, this is not normally a great idea. You're going to want to have firewalls or application gateways and things in between. But if you ever needed to have a VM that was accessible from the open internet, you would just assign it a public IP. And so a VM can have a public and a private IP that's not conflicting. So I did talk about network security, and the thing we'll talk about is the network security group. And this is abbreviated as NSG. Now, a network security group is just a type of access control list which blocks traffic inbound and outbound from the subnet it's assigned to unless it matches certain predefined rules. So these rules are based on 5 elements, and this is the source IP of the traffic, the port number, the destination IP of the traffic, and the destination port number. It also looks at the protocol, whether it's TCP or UDP or other. Now, wildcards are supported, so you can say source all IPs or destination all ports, things like that. And NSGs, you can configure them to allow traffic between different subnets on the same network. So all you got to do is just add a rule that allows traffic from a specific source into that subnet, and then traffic will be allowed to flow in. So there are allow rules and there are deny rules. And rules have priorities. So it's not going to try to find a rule that matches. It's going to find the first rule that matches. So you can have a number of allow rules, but if a deny rule that matches comes with a higher priority, then that's the one it's going to choose. Anyways, that's a good overview for now on networks, subnets, network security groups, and how virtual machines connect to it. We still got more to talk about, and we'll come back in the next video. Now, we saw in the last video that you're setting up a virtual network on your subscription, and you can divide that network into subnets, and you're going to add virtual machines generally into those subnets. And you can pretty much set up communication between those subnets, between virtual machines on those subnets using network security groups. Now, what happens when you want to connect a virtual machine on one subnet that needs to talk with a virtual machine on a completely different network? You can't do that using NSGs. And so the solution for that, one solution, is called peering. Now, basically, communication is blocked between two subnets on different networks by default. In order to get around that, you're going to set up a peering relationship between those subnets. This is going to allow communication between a VM on one network and a VM on a different network. And one of the requirements, of course, is they can't have conflicting IP addresses. So make sure that you are assigning addresses that don't repeat on other networks. Another concept within Azure is called the DNS, Azure DNS. Now, you may have heard this term before. A DNS stands for Domain Name System. It's the same system that we have to resolve domain names into IP addresses. So, for example, you have Microsoft.com. You type Microsoft.com into a browser. Well, the domain name system is going to look up what's the IP address associated with Microsoft.com, return that back, and then your computer is going to use the IP address to connect to the server. Now, there is a DNS, a private DNS inside of Azure, and that allows you to give your private IP addresses names that are more easy to remember, as well as allow the IP address to change without the connection being broken. So DNS only applies internally to Azure. If you're going to assign a domain, a IP address, a name using the Azure DNS, it's not going to work outside of Azure. So I'll give you some examples. Sometimes you'll see the .local domain being used internally. So you can assign the IP address of your development machine to be development.local. You can assign the database to be database.local, staging 1, etc. Those are all not useful domain names on the public internet, and anyone can reuse them internally because the DNS is private and unique to that network. Now, you can also assign a public domain like mydomain.com or whatever your domain is into Azure DNS, but it still will only work locally. If you're going to use a public domain name like .com, then just be warned that you're still not going to be able to use your desktop to connect to this domain unless you're running a VPN, which means you're connected to that network. Or you add the IP to your own local host file, for instance. Right, let's talk about VPNs. Now, you may have heard this term as well. The virtual private network allows a computer or a network to connect to another network, and it actually encrypts the traffic between those 2 points. This is considered an extremely secure way of communication. And so not only do you have to meet certain security authentication requirements, like a certificate or a complicated password, but the traffic is encrypted as well, so it's doubly secure. Now, many of you might use a VPN to connect. Now, if you want to set up a VPN on your company network, you're going to require a physical device. It's actually a piece of networking hardware that needs to be installed on your network in order to set up the one side of the VPN. Inside of Azure, of course, we're not installing any devices, but there's a virtual private network gateway, and that's a virtual device that you would attach to your network, and a VPN gateway uses its own subnet. So, for instance, if you work from home, you're probably using a VPN, perhaps, to connect to your office network, and then all of the servers and files on that office network appear as if you're at your desk at work. This is called a point-to-site or P2S VPN. Just to finish the analogy, your desktop computer, that single machine, is the point, and the whole network on the other side is the site. And so we're talking about peering just a few minutes ago. There is a way to connect two networks using VPN devices, and that's a VPN form of peering, different than the peering that we were talking about. So a VPN device that connects to another network is called a site-to-site VPN, or S2S. And so you can connect two or more of your offices to an Azure subnet, or you can connect the offices to each other using site-to-site VPN. Finally, there is a technology in Azure called ExpressRoute. So ExpressRoute is like a VPN, but it is faster. If you're going to be communicating to Azure and you require high speed, then you might want to look into ExpressRoute. And ExpressRoute is considered a private connection from your internet service provider to Azure's internet service provider, or their endpoint. And this means your traffic never travels over the public internet. Assuming you have a direct connection to your ISP, then you are then having a direct connection into Azure and then a private connection inside of Azure, so it never travels over the public internet. This, besides you being able to encrypt that traffic at your own, if you wanted to, it allows the traffic never to have even traveled over the public internet, which will stop people from even knowing that that traffic exists. So that's my overview of networking within Microsoft Azure. So let's talk about the concept of public and private endpoints. Now, anytime you create a resource in Azure, it has kind of different implications when it comes to who can access it and how. For instance, when you create a storage account, you can see here the default selection is to enable public access from all networks. This includes the internet. Now, again, this doesn't mean that anyone on the internet has access to the contents of your storage account. You still need an access key or authentication in order to be able to get into it. But the question is, does it even have a door that's open for anyone to try to get into from the public internet? You also have the choice of having public access, but only from selected virtual networks. And so we can add access from the storage account to this VNet1 demo that we previously created. And only devices on VNet1 demo can access the storage account. So the public internet is not one of them. So this actually makes it so that it's not possible, even with the access key, to access the storage account from the public internet. But any device that is on this virtual network that has the right key can access the storage account. You do need to enable what is called the Microsoft.Storage endpoint on the subnet. So the subnet does have to have what is basically a proxy for the storage account on the subnet, so that the communication can go from this Microsoft Azure service to your private network. The third option is what's called private endpoints. And so you can just disable all access, and then you would have to create what's called a private endpoint that would then allow private connections to this resource. And so you basically have to, for anyone who needs to access this storage account, you do need to create a private endpoint and a private link on the other side in order for that connection to happen. It's basically direct one-to-one routing as opposed to open for anyone with the access key. Now, this does not just apply to storage accounts. So SQL databases and Cosmos DB, a Key Vault, all sorts of resources that have a public endpoint that can be enabled or is enabled by default. You can also make it private to a specific virtual network, or disable that entirely and only have one-to-one connections between that resource and other resources. So these three options, it's just an indication and indicative of what you find when you go to create resources almost anywhere within Azure. The ability to have public access, selected virtual networks, or even just private access. And that's going to be a consideration for your security. Obviously, it's more difficult to use the private access, but it's more secure. The public access isn't insecure, but some people don't even have like having a locked door to the public internet that hackers can then just repeatedly try to get into, even if they don't succeed. That to some people is a security vector they want to just shut off completely. And so disabling public access is definitely the higher security way to go about this. We started off this course by quickly creating a virtual machine. And in this set of videos, in this whole section, I want to take my time at it. I want to go into the virtual machine, connect to it, install IIS, make it a web server. And so that's what we're going to do. I am in the Azure portal. And so hopefully you can get an Azure free account, or you have access to an Azure account that you can log into to follow along if you wish. I am on the home screen, which right now shows me my recent resources as well as some recommended services. Yours is going to be a completely different layout to my home screen, of course. Now, really quick, you can change the look of this under the gear icon here, which is the settings. Under appearance, you can have your menu. Right now, my menu is docked. I like to have it handy. But you can switch that to a flyout menu such that it disappears completely. You can change the coloring if you like light or dark or blue or some other color. If you've got vision challenges, you might want a higher contrast theme. And what do you want to show when you first log in? The home page is either the home or the dashboard. So you can change the settings in there. I'm going to create a resource. So we're interested in creating a virtual machine. Virtual machine is the #1 most popular Azure service right off of this create a resource screen. I could also dive into the compute category and find it there as well. So I'm going to click the create button right off of this screen. Now, as we saw at the beginning of the course, we have tons of options when it comes to what are called images, or the operating system and software that it comes with. Now we have a wizard-like interface. There are 8 tabs currently. It does change over the years, but we are currently at 8 tabs to create a virtual machine. It can be a Linux or Windows virtual machine. Azure doesn't discriminate. In fact, I've heard Linux is the most popular flavor of operating system on Azure. So if you choose Linux, you would not be alone. Now, we know that Azure accounts are broken up into subscriptions, and that basically tells you to where the bill is going to be sent. Do you get sent to this credit card or to this corporate account? Or in this case, Microsoft Azure is going to pay for any services that I use, so let them pay for that. You're not going to necessarily have the same options that I have. Every resource we create has to go into a resource group. And so I'm going to create a resource group called new VM2 because I just created new VM. And it doesn't have to be unique across Azure, just unique to your account in the region. We have to give it a name. So this is going to be AZ new VM. It does not have to be unique as well. Now, the first really important decision you have to make is the location. And we saw briefly that there are over 60 regions of the world to choose from. Now, not everyone has access to all 60. In fact, nobody has access to all 60. Some people are going to have the core regions like US and Canada and Australia and India. Some people are going to have government regions. Some people are going to have China. Some people are going to have regions that are specific to certain types of individuals, such as top secret, etc. But these are the regions we have access to, and we get to choose. Now, it makes sense to put this VM closest to whatever is going to be consuming it. So I'll put this in Northern Europe, but there's no really restriction. Now, there is a pricing implication. So different regions of the world are going to have different pricing. Perhaps South Africa would be more expensive than Europe, or South America, like in Brazil, will be more expensive than in other places. The concept of availability really is going to come down to what happens if this VM is no longer available. So let's say there's some scheduled update. We need to update Windows or update our software. We need to bring this VM down. Now, this is not the concept of load balancing, but really this is how do you control for expected or unexpected downtime. So this is going to allow you to specify which data center within Northern Europe, in this case it's Zone 1, do I want this virtual machine. If I choose more than one, then I will create multiple VMs. 3 VMs will be created because I chose 3 availability zones. I am not going to choose availability zones. I'm going to say no redundancy required. Trusted machines is the default. For now, I'm going to stick with standard until I have a reason to switch to trusted launches. Probably for production instance, it makes sense, right? It protects against persistent and advanced attacks on Gen 2 virtual machines like TPM, which protects your root from being hacked with a rootkit. Now, there are literally hundreds and hundreds of images to choose from. I'm going to say see all images. And this is going to take us to the marketplace, and this is where both Microsoft and third parties are going to make images available for use. So you might think, oh, these are operating systems like Windows, like Linux. Not always, right? Sometimes you're going to have the operating system plus a set of software that runs on top. So for instance, I can scroll down a little bit and I can see SQL Server 2022. So this is a combination of both Windows Server 2022 with pre-installed SQL Server 2022 on it. And then you get to choose your license, developer license, a web license, enterprise license, standard license. If I wanted a SQL Server license, I could choose this one. It costs more because SQL Server does have a licensing cost, but there are options for virtual machines besides that. You can see there's a developer machine that comes preloaded with Visual Studio. We also have third parties. So some of these Ubuntu's and CentOS are not provided by Microsoft, but they're provided by third parties. So if you have an Oracle DB or you have a VMware, you want some type of specific setup, you can do this in the selected image. And literally, there are 360 pages of options. So I'm going to keep it simple. I'm going to close out of this, and I'm going to choose one of the predefined options, such as a Windows Server 2022, which is given to me here. Now, similar to the number of images, you get to choose the number of virtual machine instance types. So if I say select a size, I see there are over 700 options that come in all types of number of CPUs, amount of RAM, amount of operations per second, storage, things like that. We can filter. So for instance, we want to filter on the size, and I want to only see really large virtual machines. Then I can filter on that. I can actually see that if I go under D series, I can choose a 32 CPU or a 48 CPU option when I filter based on large size. I'm going to X out of this, and I will stick with the DS1 server. We saw in the video in the beginning that you need to, for Windows machines, create a user ID and password. Done that. And then I can choose to open up ports. I'm going to turn this into a web server. And so I'm going to open up the web ports. Now, I don't really need to make any other options. A lot of these are optional. As I think I've told you before, I disable boot diagnostics, but I'm just going to say review and create. So you can skip all of the optional settings. So it's 15 cents per hour for this particular set of options, and I'm going to say create. So when we come back, we will take a look at this machine and we'll remote into it and be able to connect to it and see what a virtual machine looks like from the inside. Stick around. So that didn't take too long. Let's go have a look. So if we look at the compute virtual machine, we can see operation details, and we can see that it only took 32 seconds for my DS1 VM to get created ultimately. I'm going to click the blue button that says go to resource. Now this is our home page for this virtual machine. This is our dashboard. We can see everything that's going on here. We can see that the virtual machine is currently running. We can see the location here in Northern Europe. There's a public IP address that's been assigned. This is the size that we've chosen on creation as well as the operating system. So these are all of the settings that we've chosen. Now, at this point, we can start to change some of the settings. If we wanted to, we can go through here and start to make some changes to this virtual machine. First thing I want to demonstrate to you, I think, is connecting to the virtual machine. Now, we were given a warning when we created it that we would not be able to connect to the virtual machine by default. I'm going into the networking section. I can see that there are some rules that do allow inbound access to RDP. So let's test that. So the way I'm going to connect to this through RDP is using this connect button at the top of the overview screen. Now, when I say connect, it's going to give me the option of how I want to connect. So I'm going to connect to it using a public IP address. That makes sense. Remember, I assigned an admin user ID and password when I created it. And the most common way to connect to it is what's called native RDP. So it's RDP running on my local machine. It comes with almost all the versions of Windows for the last 20 years. So chances are you have RDP if you have Windows. And I'm going to say select. And so now it's validating that I can access the port and everything is going to be looking good. And when that gives me all the green check marks, I can say download RDP file. And I'll do that. And you'll see that it's giving me a file that is in my Chrome status bar here. And if I click it, it's going to open it and run it. So now this is remote desktop, RDP. And right now, the first time you connect to a machine, it doesn't trust the machine. So this is a, do you want to connect? Do you trust this machine? I created it, and so I trust it. So I'm going to say connect. Now, first thing we're going to find is we gave it a very unique user ID and password, and it's not the same credentials I use on my Windows machine here to log in. So I have to choose this more choices and use a different account. Now I can type in the user ID and password that I assigned when I created the machine and say OK. Now I have to check that the remote certificate is valid, and I'm going to say yes. And so now I'm connecting to this machine remotely for the first time. So I'm going to get all of the things that you get when you log into a Windows server for the first time as a user. It's going to create me a profile, create me a desktop, the directory for me, etc. Now remember that this virtual machine does not come pre-installed with almost any software. We did not choose one of the images that had a lot of things installed. And so when we go to the Windows menu for this machine, there's almost nothing there. It's like just Windows related items and server. Now when a Windows server starts up for the first time, I'm going to say no for remote connections. There is this thing called Server Manager. And Server Manager is going to allow us to do configurations on this machine. Now I want this machine to be a web server. And so the way to do that is by saying add roles. You do not need to know this for the exam, but we're going a little bit deeper into creating a virtual machine and setting up this demo just to make it interesting, as well as hopefully you're going to pick up from me how easy it is to create these machines and manage these machines through the Azure portal. So I'm going to choose the web server IIS role, and that's checked, and I'm going to say next. I'm just going to accept the defaults. I could set up an SMTP server and a web and FTP server and things like that. I'm not going to worry about that. And now I say install. So now it's just going to go off and create a web server on this local machine that I will be able to access from outside of Azure because I opened up the correct ports for that beforehand. I'll let that run. Now, while that is running, I'm going to minimize this RDP and go back to the portal. Now, one of the good things about Azure virtual machines is that I can change my mind about many of these things. Of course, I can't change the operating system. I basically should just create a new machine. But if I wanted to change my mind about the size of the machine, I could easily go to this size setting. Right now, I am DS1 virtual machine. I could upgrade to a DS2 virtual machine, add a second CPU, double the amount of memory. Doing this is a disruptive operation, obviously. It's going to shut down the current machine and restart the machine using the new credentials. So while I'm installing IIS, it probably doesn't make sense to do a resize, but this is where I would do it when I am ready to do that. Going back to the server manager, it did install IIS. I can close out this. To show this, I can start Microsoft Edge as the browser. And I'm going to basically ignore all of the startup Microsoft. We're starting everything for the first time here, so we're going to have to suffer through some of this. But what I want to do is I want to navigate to localhost and show you that there's actually a web browser running on this machine. So I create a new tab and I say localhost. Also remember that this is a 1 CPU, 3.5 gigabytes of memory machine. So it's not going to be very responsive or fast. Probably we don't have SSL installed. There we go. Localhost on port 80 returns our IIS default machine. So we have a virtual machine. It is running a web server at the current time, and we can basically navigate through all the various settings and configure it however we wish, even resizing it if we need a more powerful machine. That's pretty easy to do. Now, a virtual machine is not the only option if it comes to running programs, especially websites. There is also something called a web app. So a web app is a higher level of abstraction. You are not so much dealing with the underlying servers and backups and all of these things. The options you have in terms of server level options are more limited, but it is actually give you a lot more flexibility and options in terms of working with your apps. So with a web app, you're basically just deploying your zipped up code and configuration files into Azure, and Azure will execute that. And so it's a platform as a service. I'm going to say create under web app. Now I'm going to put this in the same resource group in new VM2 we were just working with, just for the sake of keeping them everything together. Now when it comes to web app name, it is a globally unique requirement. So there's this .azurewebsites.net URL that you are setting at the same time. So the name that I choose is got to be something that no one else has used. Another unique thing about web apps is that you have options when it comes to whether you're deploying specific runtime code. So .NET Go, which is a new option, Java, Node.js, PHP, Python. These are some of the options. There is such a thing as a custom handler. And so if you have something outside of this that you want to do, you can choose a custom handler. We also have the option of deploying